The ocean has a second seafloor that isn't rock, isn't sand, and isn't even in one place. Here's the true mind-bending part. Every single night, an entire layer of life, billions upon billions of animals, moves upward together, and then before sunrise it sinks again, disappearing into the deep like it was never there. Early sonar operators thought it was the bottom of the ocean rising to meet them. It was. It was a living layer so massive it can fool instruments, a false seafloor made of fish, shrimp, squid, and drifting creatures that reflect sound like a wall. How can a whole seafloor move? And how do most people scroll past it and miss everything? We're going down to about 1,000 meters, a depth where sunlight is basically a rumor, where pressure squeezes every weak spot, and where the ocean is no longer a place you swim. It's a place you survive. And the story starts with a mistake. Not a mistake made by an animal. Not a mistake made by a diver. A mistake made by humans staring at screens. Because when sonar first began peering into the ocean, it saw something impossible. A bright bottom appearing in midwater and then moving. Imagine you're on a ship. You ping the water with sound. You expect one strong echo from the seabed, solid rock, solid sediment, the thing that doesn't move. But the echo comes back from hundreds of meters above where the real seabed should be. Then, as time passes, that echo changes depth, rising and falling like the ocean is breathing. At first it looks like the seafloor is lifting up, like the planet itself is shifting under you. But the seafloor isn't moving, the ocean is. And what's moving inside it is life. If you've never seen the deep ocean described properly, here's the clean mental picture. At the surface, the ocean looks open and empty from above, but it's packed with life, plankton, fish, predators, everything feeding on sunlight-driven ecosystems. Go down a few hundred meters and the light collapses. Colors disappear. The world turns into silhouettes and flashes. This is the region often called the Twilight Zone, where there's still just enough dim light to be useful for hunting, for hiding, for seeing shadows overhead. Drop deeper and you enter the midnight zone, where sunlight doesn't reach at all. The only light is bioluminescence, living organisms producing their own flashes, glows, and counterfeits of starlight. And around 1,000 meters, you're deep enough that you're not seeing a reef or a wreck or a pretty seafloor landscape. You're seeing the ocean as a volume, an enormous, cold, pressurized, three-dimensional wilderness. It's here that the false seafloor makes sense, because it isn't a place, it's a layer, a living band of creatures thick enough, dense enough, and widespread enough that sonar can interpret it as a boundary, like a floor. And every night that floor moves. Let's talk about the two things that make this phenomenon so powerful for a YouTube title. First, it's real. Second, it's huge. This nightly movement is often called Diel vertical migration, Diel meaning daily. It's widely described as the largest migration on Earth by biomass, not the wildebeest, not the monarch butterflies, not birds crossing continents. This is an elevator of life moving up and down the water column across entire ocean basins every single day. And the scariest part is how casual it is. It's not a once-a-year event. It's not seasonal. It's not rare. It's routine. Like the ocean has a heartbeat. So what exactly is the false seafloor? Many scientists and oceanographers refer to a feature called the deep scattering layer. If you ever see a sonar image of the ocean, you might see a thick band that lights up and reflects sound. That band is made of organisms that scatter sound, meaning they reflect sonar pulses back to the receiver. Early sonar operators called it a phantom bottom because it looked like the seafloor, but it wasn't the seafloor. Now here's the part that changes everything. That layer doesn't stay at the same depth. During daytime, it often sits deeper, hundreds of meters down, sometimes approaching around the 1,000-meter neighborhood depending on region, season, and local conditions. At night, it rises, sometimes by hundreds of meters toward the surface. Then at dawn, it sinks again. It's like a planet-sized crowd commuting on a schedule. Why would anything do that? Because the ocean is not just dark and cold. It's violent in a quiet way. In the open water, the number one danger isn't rocks or cliffs. The danger is being seen. If you are a small fish in the upper ocean during daytime, you are basically living under a giant searchlight, the sun. And the rule of survival is simple. If something bigger can see you, it can eat you. So many midwater animals have evolved to do something brilliant and exhausting. They spend the day deep, where it's dark enough to hide, and they rise at night when the surface becomes safer to feed. And what are they feeding on? Often plankton. Tiny organisms that live nearer the surface because that's where the food chain begins. Some plankton migrate too, but many remain in upper layers where productivity is higher. So you get this daily pattern: hide deep by day, feed shallow by night, and the ocean repeats it forever. Now here's where the false seafloor becomes more than a cool fact. It becomes a story about how the ocean works. Because this migration is not just animals moving. It's energy moving. It's carbon moving. It's life turning the ocean into a giant pump. When these animals feed near the surface and then return to deeper waters, they carry carbon down with them, through waste, respiration, and sometimes death at depth. That means this daily migration is part of how the ocean helps regulate Earth's carbon cycle. So when you hear people scroll past this and miss everything, that's not drama. If you miss the deep scattering layer, you miss how massive the midwater ecosystem is, how predators hunt in the open ocean, how carbon gets moved into deep waters, why deep-sea food webs don't require constant sinking snow alone, and why changes to this zone could matter for climate and fisheries. This isn't a trivia fact. It's the ocean's invisible engine. Let's make it visual. Imagine you're in a submersible or watching an ROV feed. The water is black. Your lights only reach a limited distance. You're moving through nothingness. Then, out of that nothingness, small flashes appear. Not random, not distant stars, living flashes. A jelly drifting by like a transparent parachute. A shrimp-like creature that vanishes the second it hits the edge of your light beam. A fish that looks like it was designed by someone who hates symmetry. And then your sonar shows something, a band, a thick layer, a line across the screen. It looks like a bottom, but your depth says you're nowhere near the bottom. That's the false seafloor. And now imagine this: if you stay there long enough, if you watch through dusk, you see the layer begin to rise, at first slowly, then steadily, like a curtain being lifted. And as it lifts, the entire midwater world changes with it. So what's in this layer? Not one species, not one monster. It's a mix of creatures that share one thing. They live in midwater and have bodies that reflect sound. Some of the most common members include lanternfish, myctophids, small fish that often have light organs. They're incredibly abundant in many oceans. Krill and shrimp-like crustaceans, swarming, drifting, and frequently migrating. Squid. Some species rise at night to hunt. Gelatinous animals, siphonophores, jellyfish relatives, salps, often overlooked because they're delicate and hard to sample. Copepods and other zooplankton, tiny but numerous. Now here's a twist that explains the sonar wall effect. Sound reflects strongly off anything with a big density difference compared to water. For many fish, that includes their swim bladders, gas-filled organs that help control buoyancy. Gas is a massive acoustic contrast compared to seawater. So a whole layer of fish with swim bladders can light up sonar like a reflective sheet. That's why early sonar saw it as a bottom. Not because the ocean was lying, because the ocean was crowded, and crowded in a way that's hard for humans to emotionally understand. We're used to migration being visible, herds on plains, birds in the sky. But this migration happens in darkness, under pressure, with creatures that don't want to be seen. So for most of human history, it happened unnoticed. And even now, people can watch a deep-sea video and not realize that the empty water is full of movement just outside the light. The deep scattering layer is like the audience in a stadium when the lights are off. You don't see the crowd, but the crowd is there. And when it stands up together, you feel it. So why does it move specifically at night? Because night changes the risk equation. During the day, predators from above can use light to hunt. Even dim light is enough for certain visual predators. At night, that visual advantage collapses. Many animals still hunt with senses other than sight, lateral lines, smell, electroreception in some cases, but darkness still changes the rules, and the migrating animals exploit that. They rise to feed near the surface under cover of darkness, then sink before sunrise. This dusk rise and dawn sink behavior is so consistent that in some places you could almost set your watch by it. It's like the ocean has shift changes. Night shift goes up, day shift goes down. Now let's address the title again, 1000 m deep ocean. Why that number? Because that's around the zone where these animals can hide during daylight and still return to feed at night. But the exact depth varies. The ocean is not a single uniform tank. In clear open ocean regions, animals might go deeper to hide because light penetrates further. In productive or turbid regions, the safe darkness might occur shallower. And temperature layers, oxygen levels, and predators also change the rules. So the false seafloor isn't a fixed layer at 1,000 meters. It's a moving layer that can occupy that kind of depth range, especially in daytime, then rise toward the surface at night. The key is movement, not the exact number, because movement is the shock. Now imagine what happens to the predators that know this schedule. If you're a predator in the midwater, you don't have to roam randomly. You can hunt the edge of the moving layer. You can wait for it. You can rise with it like an elevator passenger, feeding as you go. Some predators make their own vertical migrations to track prey. In the ocean, where to hunt isn't just a location. It's a time. It's a depth that changes. It's an appointment. And it happens every day. This is where the story becomes cinematic. Because the ocean at night is not calm. It's not quiet. It's just dark. And darkness hides traffic. When the scattering layer rises, it's like opening the gates to a city. Creatures flood upward, and with them come the hunters. You get chase behavior, ambush behavior, flashing displays, counter-illumination tricks. Counter-illumination is one of the coolest survival hacks in the deep. Some animals produce light on their undersides to match the faint glow from above, erasing their silhouette when viewed from below. So as they migrate, they're playing a game of camouflage while moving. It's like driving at night with your headlights tuned to match the color of the sky, so you don't cast a shadow. That's how intense the visual arms race is in the ocean. And the false seafloor is where that arms race concentrates. Because that layer is basically the busiest part of the water column at certain times of day. If you want to understand the ocean's food web, you don't just look at the surface. You look at the moving layer beneath it. Because it's feeding time down there in a way that is almost industrial. Now, how did humans realize what this was? The short version is sound. Sonar doesn't need light. It pings sound waves and reads echoes. When sonar became common, operators began seeing that phantom bottom layer. At first it was confusing. It could create false readings. But over time, scientists connected the dots. The echo was coming from organisms. The layer's movement matched dusk and dawn patterns. And as sampling improved, nets, acoustics, optical tools, researchers confirmed what was causing the scattering. It wasn't geology, it was biology. There's something humbling about that. We built machines to see the ocean, and the first thing the ocean showed us was a trick. Not an intentional trick. Nature doesn't care about our instruments, but a reminder. The ocean doesn't organize itself for our convenience. A sonar echo doesn't mean rock. It means something that reflects sound. And sometimes, something is a living wall. Now let's go deeper into why this matters, because this is where people underestimate it. The deep scattering layer isn't just cool, it's potentially one of the largest habitats on Earth by volume. Think about it, forests are thin layers on land. Even rainforests have height, but Earth's surface is mostly ocean. The midwater zone, hundreds of meters thick across vast areas, is enormous, and it's not empty. So when people casually say, "We know more about space than the ocean," they're gesturing at something real. There are enormous parts of Earth's biosphere that are poorly measured, hard to sample, and constantly moving. The scattering layer is a perfect example. We detect it, we map it in places, we study pieces of it, but it's huge, dynamic, and full of species that are difficult to count accurately. If you're trying to measure how much life is in the ocean, this layer is a big part of the answer, and also a big part of the uncertainty. And then there's the climate angle. When these animals feed near the surface and then excrete waste deeper down, that waste becomes sinking carbon. When they respire at depth, they release CO2 deeper down. When they die and fall, that's carbon transport too. This contributes to what people broadly call the biological pump, processes that help move carbon from surface waters into deeper ocean layers, where it can remain for long periods. So a daily migration of massive biomass can influence how carbon is distributed in the ocean. That means changes to this layer, due to warming, oxygen loss, acidification, fishing pressure, could matter more than most people realize. Not because one fish matters, because a living layer that spans oceans is not a small component. It's infrastructure, it's the plumbing. Now when you hear people scroll past this, here's what I think that really means psychologically. People assume the ocean is empty because the camera shows emptiness. But cameras lie, not intentionally but physically. A deep-sea camera has a small light range. Most of the ocean is outside that range. So we watch a video and think nothing is there, when in reality, the video is showing only a tiny bubble of visibility. The scattering layer makes that limitation obvious, because sonar sees what the camera can't. Sonar sees density and reflection beyond the beam of light. And it reveals a hidden city. So if you're watching a deep-sea clip and you're not thinking about what's just outside the light, you're missing the majority of the scene. You're looking at the stage, not the crowd. Let's do a quick thought experiment. You're floating in the ocean at night, far from land in deep water. Above you, a surface that looks calm. Below you, blackness. Now imagine that below you, starting hundreds of meters down, there's a rising tide of organisms, like a swarm but more organized, more layered. Tiny drifters, shrimp-like creatures. Small fish with lights, squid with eyes tuned to darkness. They're rising because they know the surface is safer now. And then imagine what happens when the moon rises or when dawn approaches. That entire migration pauses and reverses, like a building evacuating at exactly the same time. It's not one animal making a choice. It's evolution programming millions of choices into the same schedule. The ocean is running an algorithm, so why don't we see it clearly all the time? Because it's not one dramatic animal, it's a pattern. And patterns are easy to miss unless you know to look for them. But once you know it exists, you can't unknow it. The false seafloor becomes a lens. You start to understand why deep-sea predators are where they are, why some fishing strategies target midwater layers, why certain animals have huge eyes and light organs, why the ocean at night is different even if the surface looks identical. Now, let's address the phrase "moves at night" carefully. It's not that the layer is asleep and then wakes up. It's responding to light levels. Many animals are extremely sensitive to light changes. Even small shifts can trigger movement. That's why dusk and dawn are the key transitions. During full daylight, the layer is deeper. During full darkness, it's shallower. But night is the headline because that's when the movement becomes most obvious and dramatic. Also, it's when it feels most like a secret, because we're asleep. and the ocean is commuting. There's another piece of this that makes it even more surreal. The scattering layer isn't always a clean single band. Sometimes it splits into multiple layers. Sometimes it's patchy. Sometimes it's thicker or thinner. It can vary by season, region, productivity, temperature, oxygen, predator presence. In other words, the false seafloor is not just a thing. It's a living symptom of ocean ecology. If it changes, it tells you something has changed in the system. So scientists don't only care that it exists. They care about how it behaves because its behavior is data. Now let's connect it back to 1,000 meters again. At 1,000 meters, the ocean is cold, dark, and pressurized. That depth is also a kind of boundary region between midwater ecosystems and deeper ones. Some migrating animals go that deep in daytime. Others go deeper or shallower. But the important point is, around this depth, you can sit in darkness and watch the layer above you change. You can detect it with acoustics as it rises. You can watch bioluminescent signals shift as animals move through. You can observe predators that track it. It's like standing on a balcony in a city and watching the traffic patterns change between night and morning. Same streets, different flow. Now, one of the most underrated parts of this story is how it changes what we think deep sea even means. When most people picture deep sea life, they picture the seafloor, vents, trenches, weird bottom dwellers. But the ocean is mostly not seafloor, it's water. And the midwater world, the pelagic zone, is where a massive amount of life happens. The scattering layer is proof that the deep sea is not just the bottom, it's the space between. And that space is alive. If you want a single sentence that captures the shock: the ocean's busiest neighborhood is invisible to your eyes but loud to sonar, and it moves on a schedule. That's the false seafloor. So what should you look for in footage, in animations, in explanations? Look for a thick band on sonar or acoustic data, mention of the deep scattering layer, dusk-dawn changes, vertical migration, lanternfish, krill, midwater squid, predators that follow prey upward at night. The concept that night makes the surface safer. Once you lock onto those ideas, you'll notice the pattern everywhere. Even in documentaries that don't highlight it, you'll start seeing the clues. The timing, the depth, the swarms, the light organs. You'll realize the ocean isn't empty. It's just hidden. And now the final punchline of this whole title. People scroll past this and miss everything. Because this phenomenon is not a weird one-off. It's one of the most important daily movements on Earth. It links surface life to deep life. It feeds predators. It transports carbon. It shapes how the ocean breathes and cycles nutrients. And it happens whether we notice it or not. If you enjoyed this kind of deep ocean reality, real, creepy, and way bigger than it sounds, hit like and subscribe, because we're building a full Abyss series where every episode is a real phenomenon that sounds impossible until you actually see it. And in the next one, we can go even stranger. Because if a false seafloor can move every night, wait until you see the places where the ocean has lakes inside itself. Brine pools that look like shorelines but act like traps. For now, remember this. In the deep ocean, the most shocking secrets aren't always monsters. Sometimes it's the fact that the ocean itself is moving, quietly, like a living machine.